Well, in this particular video, we are going to talk about conditional statements as we continue our study of logical thinking. And of course, remember in the last video, we basically alluded to this because we talked about the conjunction, the disjunction, and we also briefly mentioned the implication, which deals heavily with the conditional statement. So what is a conditional statement? And by the way, before I go on any further, you might think that this sounds a whole lot like English. And it does kind of feel like English, even though we're studying logic. But that's a very important part of how we think about in geometry, because we do a process called deductive reasoning. And so you're wondering, well, why am I kind of having to deal with these if-then sentences and what really seems like an English class? This is supposed to be about shapes and stuff, but we're talking about logic, and that's the reason why. So what is a conditional statement? Calling from the back, what is a statement that's called a conditional statement? Well, that's right. It's a statement that is written as an if-then sentence. It means it's a format of the sentence is if and then. Okay, so it has the words if and then involved in it. And so the format of a conditional statement, it has two parts. And it's very important for you to remember that a conditional statement is joining two statements together, just like the conjunction and the disjunction join two statements together. A conditional statement is joining two statements together, both which have their own truth values. So a conditional statement has a hypothesis, and a conditional statement has a conclusion. And just so you understand what those words mean in relation to a conditional statement, is the part of the conditional that comes after the word if, but before the word then, that's called the hypothesis. And the part of the sentence that comes after the word then, that is called the conclusion. So you understand how the conditional is structured. So a conditional is structured in this way, and you probably might have already known that. But just so you know, we do use this idea in geometry, and it helps us to prove whether things are true or false or not. And so we're going to break down an example of a conditional. So the conditional statement that I made up for you is a basic, simple conditional. And it is, if a triangle has three equal sides, then the triangle is equilateral. Okay. And so right now we're just looking at the different component parts. We're not doing anything else but looking at the different parts. So in this particular sentence, the hypothesis is a triangle has three equal sides. The conclusion is the triangle is equilateral, and that's how it looks. And so let me go back and just let you take a look there. If a triangle has three equal sides, then the triangle is equilateral. The hypothesis, the triangle has three equal sides. The conclusion is the triangle is equilateral. That's the way that particular statement works as far as that conditional goes. Now, if you want to represent this conditional, but you don't want to write actually all those words out, you want to be done with basically 3 characters because you don't feel like typing out all those words over and over again, well, we can represent conditionals just like I showed you how we could represent statements in a previous video. We can represent conditionals in a very similar format. Okay, but what's important here is that you remember what the important pieces are here. Okay, the statement P, which is the hypothesis, can be a triangle has 3 equal sides. The statement Q can be the conclusion. The triangle is equilateral. And by the way, do you have to use P and Q? No, but for some reason in geometry and in other logical reasoning, whether it be programming or whatever the case is, whatever you're doing, they like to use P and Q as the first variables. I don't know why they do that, but that's what they do. So you do whatever makes you happy as far as that's concerned. But what is important here is how we represent it symbolically. So if I want to say this statement, if a triangle has three equal sides and the triangle is equilateral with symbols, I use a P and an arrow and a Q. It means the same thing, and I don't have to write all of those particular words out. Okay. Now I can also write statements with negations and whatnot. I'm not going to show you that right here, but just remember you can write similar statements that mean different things if you add the not symbol in or the tilde, because remember that's negating a statement there. Now, what is very important is the truth value of conditionals. So what you need to remember about a conditional statement is a conditional statement is different from its component parts, right? So conditionals have a hypothesis and a conclusion, and then it has the entire statement. Well, the entire statement is a unique statement in and of itself, right? So you have a hypothesis that can be true or false, you have a conclusion that can be true or false, and then you have the entire conditional, which can be true or false. And so conditional statements have four possibilities if you're joining just two statements together. And three of those possibilities are true, and the other one is false. And so let me show you what this looks like in a truth table. For the truth value of a conditional, if the hypothesis is true and the conclusion is true, then the whole conditional is true. If the hypothesis is false, and this is where it might get a little confusing, but I'm going to show you an example to make this easier to understand. If the hypothesis is false and the conclusion is false, the entire conditional is true. Now, this does seem a little confusing. I get it. So stay with me, though. If the hypothesis is false, but the conclusion is true, the entire conditional is true. And the only instance that is false is if the hypothesis is true, the conclusion is false, then the entire conditional would be false. And you might ask yourself, well, how does that work? That doesn't make any sense that for it to work that way. Remember, this is logic, and we're dealing with true and false outcomes. And let me give you this little scenario that hopefully will help you make it easier to understand. So, say your best friend tells you, if you make straight A's, then I will buy you a car. That would be a pretty good best friend, by the way. So if you have a best friend that can buy you a car for making straight A's, number one, that's good on a whole lot of different levels beyond the scope of this video. But if you've got a best friend that would do that for you, then I would encourage you to keep that best friend. But suppose your best friend tells you, if you make straight A's, then I will buy you a car. When has your friend lied to you? Look at these four different scenarios and let's decide when your friend has lied to you. Is it A, when you make straight A's and he or she buys you a car? Well, your friend told you, if you make straight A's, then they'll buy you a car. So no, clearly they haven't lied to you in scenario A. What about scenario B, when you do not make straight A's and he or she buys you a car? Have they lied to you there? Well, you might think that they've lied to you there, but they really haven't, because your friend didn't say anything about what they were going to do if you did not make straight A's. They only told you about what they were going to do if you did make straight A's. So in this scenario B, when you do not make straight A's and he or she buys you a car, that doesn't that is not a lie, because they didn't say anything about what would happen if you don't make straight A's. And so part C kind of goes with part B there. When you do not make straight A's and he or she does not buy you a car, that scenario is still true because they haven't lied to you, because they didn't say anything about what would happen if you did not make straight A's. So B and C are both true in that instance. The only time they would have actually lied to you would have been if you made straight A's and then he or she did not buy you the car, because they said if you make straight A's, then they would buy you a car. So in this place, if you make straight A's, that means the hypothesis was true, but then the conclusion was false. That's the only time that it would be false. So we hope you've enjoyed this video about conditionals. Hope you'll begin to understand how these work a little bit. And we look forward to seeing you real soon. I'm Steve Rachel. Thanks for tuning in.